Hi guys, my name is Vinay Jain and today we're going to be discussing Leetcode question 112 path sum. So the question is, given the root of a binary tree and an integer target sum, return true if the tree has a root to leaf path such that adding up all the values along the path equals target sum. So what does this question mean? So let's assume that this is the binary tree that we have and the target that we're looking for is 22. We have to match this target with the path sum. How is the path decided? So the path is decided based on a root to leaf path. So leaf nodes are these 7, 2, 13 and 1 in the sample binary tree. So any path from root to any leaf tree, any leaf node. So let's assume that this is one path, right? So does the sum of all the nodes involved in this path, which is node 5, node 4, node 11 and node 7, does the sum of all these nodes add up to the target? If yes, then return true, otherwise check other paths, and if you are exhausted with all possible paths, then return false. So for the path highlighted, which is this path, what is the nodes sum along this path? So it is essentially 5 plus 4 plus 11 plus 2, right? Because these are the nodes involved and the sum of them is 5 plus 4, 9, 20, this is 7, my bad. This is 27. This comes out to be 27 for the path sum for this path. Is this equal to the target? No, it is not. So we check a different path because this path is not a valid answer. Let's assume this path because this is also a path from root to leaf node, right? So what is the sum of all the nodes along this path? So 5 plus 4 plus 11 plus 2, right? Sorry, my bad. So this adds up to 22. So for this path, the sum of all the nodes added up comes out to be 22 and this is equal to our target, and therefore we return true because we have found a path from root to leaf node in the given binary tree where the target equals 22, where the sum equals the target 22. So how can we compute this? As shown in the example, we're going depth by depth in every node of the tree. We're traversing the tree in a depth first search order, and therefore we're going to be using a depth first search modified algorithm for this approach. So how does this work? We're going to be using a stack data structure because that is what we use in our depth first search algorithm to facilitate depth first search idea. And we're going to be using a pop node to keep track of the current node that we're working with. So let's say this is the stack that we have. Just a moment. So we insert the root node in the beginning to the stack, and then as long as the stack is not empty, we pop the topmost node in the stack and assign it to pop node, right? So the pop node is 5 right now. Is it a leaf node? No, it is not. So we check what all children does it have, and we propagate its value, its sum, which is its value currently, to its children nodes. So for the right child, does it have a right child? Yes, it has. So to its right child, we propagate its sum, which is 5, and we add that to the right child's value. So 8 plus 5 becomes 13. So the previous value, the original value for this node was 8, but now we replace this value with the cumulative sum from root to the current node, which is 8 plus 5, and now the value is 13. So this value from 8 is now replaced by 13. So this is the value of the current node, and then we push this child node of 5, the new child node of 5, which is 13, to the stack. Similarly, we work with the left child of the current pop node, which is 5. So this is the path that we're looking at, right? So we propagate the sum encountered so far, which is 5, to its left child node. So 4 plus 5 becomes 9. So this is essentially now the new value of this node, signifying that the path for this path, the sum is till this node comes out to be 9. So this is how we're storing this information. And now we push this node onto the stack as well. So 9 is pushed onto the stack. Now we pop whatever is at the top of the stack, which is 9. So we pop it, assign it to pop node. This is the node that we're currently working with. That means this node, the left child node of node 5. So this is where we're currently working with. Is it a leaf node? No, it is not. So does it have any children nodes? It has a left child node. So we propagate the sum that we have, the value of this node, to its child nodes. So its left node becomes from 11, the value is added, the 9, the parent value is added 9. Since this is the value that we want to propagate below in the depth, so this value now becomes 20. So this new value, the new cumulative sum, is essentially replaced here. So 20 replaces the old value 11 for this node. And then we push this node onto the stack. From 11, note that we do not push the node 11. The node 11's value now is node 20. Its value is 20, so that is what we push onto the stack. Next, we pop whatever is on the top of the stack, which is again this node 20. Assign it to pop node, signifying that this is the node that we're currently working with. So what is it a leaf node? No, it is not. So we work with its children nodes. So it has a right child, right? So we explore this side first and propagate our sum so far that we have encountered along this path to this new path now, to this new child node. So 2 plus whatever the sum we have encountered so far, 20, that equals 22, right? So this is essentially the new value of the current node. So this is replaced by 22. This is replaced by 22. And for the time being, let's assume that the target that we're looking for is not 22, it's 26. So now we push, while we're at this step, once we have updated the child node's value, we push this node onto the top of the stack, which is now like this. And we explore the current pop node's left child. We're still working with node 20, right? So its left child is yet to be explored. So we propagate our sum there. So 7 plus 20 becomes 27. So this is the new node. This is the new value of the current node. And we then push this node onto the top of the stack. Now we pop whatever is on the top of the stack, which is node 27. So we pop this and assign it to pop node. So node 27 is what we're actually working with right now. So is it a leaf node? Yes, it is a leaf node. That means we have calculated the sum of all the nodes involved in a path from the root to the leaf. Now is this sum equal to the target that we're looking for? No, it is not, right? The sum we've encountered in this path is 27 for this leaf node and the target is 26. So therefore we explore a different path. Sorry, my bad. So now we explore a different path. And how do we do that? We pop whatever is next on top of the stack, which is node 22, and we assign this to pop node. So this is essentially what we're working with right now. Is node 22 a leaf node? Yes, it is. So if it's a leaf node, that means we have calculated the sum of all the nodes involved in a path from root to this leaf node. And the sum is 22. Is it equal to the target? No, it is not. So therefore we explore other possible paths. Again, then you pop whatever is at the top of the stack. What is at the top of the stack? Node 13. So you pop this and assign it to the pop node, signifying that this is the current node that we're working with. So node 13, that is this node, this is what we're working with. Is it a leaf node? No, it is not, right? So we explore its child nodes. So it has a right child node 4. So from root node till here, the sum is 13. And then we propagate this sum to its child node. Right now we propagate its sum to its right child node. So this becomes 4 plus whatever sum we had so far, 13, along this depth. So this now becomes 17. And this 17 is the new value for this node. So the right child of node 13 becomes 17 and we push this onto the top of the stack. So all these nodes are done. So the top, right now the stack is empty and we push 17 onto the top of the stack. Next, we're still working with pop node 13, right? So we explore its left child node. Its and we propagate our sum so far along this path to this node. 13 plus 13 becomes 26. So this is essentially the new node value for this node. Now that this is done here, we add this node, the new node 26, to the stack. Once we have done this, we pop this whatever is at the top of the stack as the next iteration step and assign it to pop node, just like how we do it in DFS. Now we check whether the current node that we're working with, is it a leaf node or not? It is a leaf node, right? So whatever the path sum is along this path from root to leaf node, the sum for that is 26. Is this equal to our sum, target sum that we're looking for? Yes, it is. So that means we have found a path from root to leaf node where the sum equals 26, which is equal to the target sum, and therefore we return true. So what is the algorithm for this question, for this problem? So the algorithm is very straightforward. Just like DFS, initialize empty stack and add root node to it, the beginning part of the DFS. And as long as the stack is not empty, pop the topmost node from the stack. If pop node has the right child, add pop node's value to the right child, and then add the modified right child to the stack. Similarly, for the left child, if the pop node has a left child, add pop node's value to left child's value, and then add the modified left child to the stack. If pop node is a leaf node, check whether it's a leaf node or not. If it is, then check whether the path sum that we've encountered so far is equal to the target sum or not. If it is, return true. Otherwise, keep iterating as long as the stack is not empty. Once the stack is empty, that means we've worked with all the possible nodes in the tree and we still haven't found any answer. That means such a path doesn't exist and therefore return false. So this is essentially the algorithm for path sum question. I hope this video helped understand the concepts and how to work with this question. Thank you for watching this video. Have a nice day.